Welcome to the Crazy Hat Chemist. So another video in thermochemistry. Bam! So today we're talking about units of energy and the specific heat capacity. So energy is expressed as the joule, which is not an international system of units, so that's an SI unit, but is derived from a variety of them. So here it is. 1 joule is equal to kilograms times meters squared divided by seconds squared. You're going to have to memorize that. That's a really important unit conversion from SI units of kilograms, meters, and seconds all the way to joules. Okay? Very important. Okay, another unit conversion here for us is 4.184 joules is equal to 1 calorie. Okay, and then we should also know that 1,000 calories is equal to 1 capital C calorie, that's a food calorie, is equal to 1 kilocalorie. All right, so this is a very important definition. The quantity of heat lost or gained required to change the temperature of 1 gram of a substance, whatever that is, by 1 degree Celsius is called the specific heat capacity, and that is labeled as the CP, or just C for capital C there for the specific heat capacity. Okay, the specific heat capacity for water, which is the most important specific heat capacity for us as a reference for everything else, is the following. 4.184 joules per gram degree Celsius. That means it requires 4.184 joules for every 1 gram of water per every degree Celsius to either increase or decrease. That it requires 4.184 joules. Notice that 4.184 joules is the conversion for 1 calorie. So it's 1 calorie is equal to 1 calorie divided by grams degrees Celsius also. Okay, so more on this. So I want you to look at this selected values of specific heat capacities, and they are all in joules per gram degree Celsius. And then I have a variety of substances. Water is in the yellow right there. I have ice, I have steam, okay? And then I have benzene, which is a carbon and hydrogen. It's a ring-like structure. I have air. There's aluminum in the aqua blue color. There's iron in the violet purple. There's copper in the orange. There's silver, gold, and lead. So these are very important numbers here. You don't have to memorize any of them except for the specific heat capacity for water, and that's 4.184 joules per gram degree Celsius. So something that you need to know, though, is the higher the specific heat capacity, the longer it takes to heat or cool that object. So 4.184 joules per gram degree Celsius for water is a very, very high number, very large number relative to the rest of these. So that means it requires a tremendous amount of heat to heat up water, and also it takes a long time for water to cool down because the heat capacity for water is so great. Okay? Converse to that is the lower the specific heat capacity, the shorter it takes to heat or cool an object. So if you look at this table here of selected values of specific heat capacities that I have, now look at the bottom where we have lead, gold, and silver. And specifically lead and gold have very low specific heat capacities. That means it doesn't require very much energy to heat up lead or gold for that mass by 1 degree Celsius, or to cool it down. Okay? This is a very important concept here. This is why we use certain metals for certain processes. Okay? Some of it is dependent upon the price of that metal, and some of it is dependent on these specific heat capacities. And I'm going to show you some examples of this. Okay? In my kitchen, I have a variety of different pots and pans, and these are by a specific brand, which these pots and pans are very heavy. And they are very heavy because they are a layer of metals and alloys together. Okay? And here is the layering. So on the inside is an 1810 stainless steel interior. Okay, that 1810 stainless steel interior is really nice for cooking. So there's no transfer of that metal, okay, to the taste of the food. There's no transfer of the food to the metal that stays with the metal even after cleaning. Stainless steel is relatively impervious to acids like tomatoes or fish smells, and it's easy to clean. Okay, and then right below that layer of stainless steel is a layer of aluminum. Then below that is a layer of copper. Then below that is a layer of aluminum again, and then below that is a layer of 1810 stainless steel or aluminum. Some of my pots and pans have aluminum on the outside, and some of them have stainless steel on the outside. The aluminum is a little bit harder to clean, but it serves the same function on the outside, not a problem. What's really important is that there's a copper core in between these, and you should see that that copper core is thicker, that has thicker copper. Now I want you to look at the specific heat of copper. It is 0.385 joules per gram degree Celsius. That's a relatively low value, okay? And the vast majority of the mass of these pots and pans are copper on the inside, okay, which has a low specific heat. Now it isn't quite as low as silver, gold, and lead, because lead is toxic and silver and gold are just too darn expensive, okay? But copper has a very low specific heat, so that means that it doesn't require very much energy to heat up a mass of copper per that mass of it. So it doesn't require very much to heat up the copper, and that copper will heat up from the fire of your stove or your oven, okay, and then release that energy to the food item and cook it faster. Okay. Now, if your pots and pans are made out of other metals, then it takes longer to heat up that pot or pan, and then it will take longer to transfer that energy over to the food item. So you want to have pots and pans with the lowest specific heat capacity as possible so that it heats up very quickly, transfers the heat very quickly as well. This is also why water takes so long to boil, because its specific heat capacity is very high. That's why you can start up that stove, put the water in there in that giant pot to boil some pasta, and it takes a long time to boil that water because the specific heat capacity for water is so very high. Okay, I want you to take a look at this. This is a cast iron pot, and this is just one of many that I have. Okay, and the iron has a larger specific heat capacity. Okay, at 0.473 joules per gram degree Celsius. And we use this cast iron pot at home for cooking stews in, and also for baking bread in also. If you heat this cast iron pot in the oven, then it will retain its heat because it has a higher specific heat capacity. Okay, and it's relatively dense. All right, that's some super cool stuff, and applied specific heat capacities as well. Here's another example of an applied specific heat capacity, and you look on the inside of a computer, and if your computer has a fan to cool down the hard drive, there's a piece of aluminum that's shaped kind of like a comb, okay, and that piece of aluminum allows the air to circulate in between the tines of the comb with the fan. Okay, and that means that all the heat energy is dumped to that piece of aluminum, and then that heat energy is dissipated out with the assistance of that fan blowing across the tines of that comb. Okay, that specific heat capacity of aluminum and the inexpensiveness of aluminum makes that aluminum a very valuable metal for that purpose. Okay, I am the Crazy Hat Chemist, and that was a cool Crazy Hat video on thermochemistry. That was the second one. We got so many more to do. Give me a thumbs up if you like that video. Subscribe to my YouTube channel. I'm going to see you next time as we continue this unit. Bye for now.